Hello guys, welcome back to my channel Code by Punch, and today we are going to solve the question sliding window maximum. Okay, so in this question we have given an array of integer nums. There is a sliding window size k which is moving from very left of the array to the very right. You have k numbers in the window. Okay, each time the sliding window moves by the right position, return the maximum sliding window. Okay, so we have actually this we have actually this elements in the array. Okay, and this is the size of window 3. Okay, this is the size of window 3, and as here you can see 3 is actually the maximum element, so we return 3. Then the maximum element here we can get is actually 3 also, so it is 3. Then when it moves further, it is -1, -3 and 5, and as you can see here, that 5 is actually maximum. Then it is 5, then it is 6, and then it is 7. So how we are going to solve this question? In order to solve this question, we can actually use for loops. Okay, we can actually use for loops, but it can be really tricky, as well as the time complexity also exceeds. So in order to solve this question, what we are actually going to do, we are actually going to use a DQ. So let me tell you about DQ. What is a DQ? So in a normal queue or a normal stack type of data structures, we actually do operations like push and pop. Okay, we only do push and pop, but in a DQ type structure we can actually push from the front. This is the front, so we can push from the front, we can pop from the front. Okay, this is the speciality of this. It is actually a doubly linked list, but here we can actually do push from the front, we can pop from the front, we can push from the back, and pop from the back. Okay, so these are the operations that we can do in a DQ. So these are the 4 operations. We can push, pop, but we can pop. Here it is pop, but this pop is from back, and here it is from front. Here the pop push is from front, and here is the pop is from back. So these are the 4 steps that we can do. So how we are actually going to solve this question? Let me tell you the intuition as well as the algorithm part. So our element are 3, -1, -3, 5, 3, 6, 7. Okay. So I will make a DQ. This is my DQ. So when I encounter with this element, what I'm going to do, I'm just going to push it into the DQ. Okay, then I will move further. This is 3, and I will check if this element which is present here, if this element is actually greater than or greater than 3 or not. Okay, so 3 is actually greater than 1. So if this is a size of k, okay, this is size of k, and if this element 1, the first element is actually smaller than this element, so I don't think we need to store this element. Okay, we don't need to store this element because it is of no use, because we have to find the maximum, right? We have to find the maximum, and in this the maximum is 3. So if we store 1 or not, it don't even matter, right? So what we can do, we can just we can pop from the front. We are just going to pop from the front, and we will just add 3. Then we will move further, and we will see, okay, this is -1. So I will push. So I will, because it don't even matter. If we want to look at the maximum value, it is from the front. Okay, from the front we can get our maximum value. So that's why it don't even matter if I put -1 here. Okay, then I put -1 here. Then this will move further. Okay, and here it is -3, so I will push -3 into the DQ. Okay, now what I can see, that when I move further, my 3 is actually not in this DQ. So what I'm going to do, I'm going to just pop from the front. Okay, pop from the front, because I don't need this now. So the new thing is -1, -3. Okay, and then I move to 5, and I see that 5 is actually greater than -1 and -3, so it needs to come in the front. So I delete and pop everything from the back, and next element is 5. So 5 is actually greater in this subarray. Then I will move my window and I will see it is -3, 5 and 3, and 3 is actually the new element that we are encountering. So 5 is actually greater than 3, so we just push from the back 3. We push 3 to the back and then we move further. And then when I move to this window 5, 3 and 6, I see that 6 is actually greater than 3 as well as 5. So what I'm going to do, I'm just going to pop 3 from the back, 5 from the back, and I can push 6 here. I can move 6 here. Okay, and 6 is actually greater, so that's why this will give us the maximum as 6. And then I will move to 7, and here as you can see 7 is actually greater than 6, so I will just put 7 here. So at the end, after the iteration, everything will be over, and I will just return my answers, whichever will be the maximum. It will be on the front of this DQ. So this is the algorithm part. Now let's move to the coding part. Here in the coding part also it is really easy. As you can see, we are just pushing the indexes. Okay, here this is the main thing, because we need the indexes, and if this is the index I minus k equal to different, this means that we have to remove, because if this is my array and this is the window size, so if something is present from this thing, I have to remove it, because the window size don't contain this. So that's why I will just DQ from the pop front. And while it is not empty, and if my num is actually greater, then as I told you, I have to remove and pop from the backward, and then I will push from the backward the DQ that if let me tell you, if this is 3 and this is actually 2 and this is 5. So first what I will do, I will just pop everything, because these are less element than 5. Then I will push 5 into this. Okay, so this is the same thing that we are doing here. And then at the end we are just going to, if I is actually greater than equal to k minus 1, then we are pushing the answer to the, because dq dot front actually keep the maximum index, and then at the end we are just going to return the answer. So I hope you like the video. Make sure to like, share and subscribe for more upcoming videos, and thank you for watching.